Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to solve problems that involve radioactive decay kinetics. Basically, like if you're given a certain situation where you have a certain amount of a radioactive substance that decays over a certain amount of time, and you know the half-life, how much is left after a certain amount of time, so on and so forth, or how much did you have originally if this is the amount of time, and so on and so forth. So I'm going to go over a few problems. In this video, I'm going to go over one of those problems. First thing I want to talk about is the equations you're going to use. Now, in your textbook or your professor or teacher might give you a couple of equations. So for example, you have here these two, and I'm going to put a box around this one. I'll explain in just a moment. Um, So you could use these two equations if you're given those two equations in your textbook or your professor. Um, you can use this quite easily. So, for example, you could solve what k is if you know what the half-life. So T1/2 is the half-life. So you could plug in the half-life, solve for the k here, and then you have k in this one. You could take the k that you got, plug that into here, and you could take the time here that you have. Like, so for example, we're given 5 years of time. We're given a half-life of 2.86 years. And you could plug all of this in here and solve for the missing part, right? So in this case, they're asking what mass is present after the 5 years. So they're basically asking us like how much is left over. So here, the n sub t is the amount that you have after a period of time. Basically, how much is left over. The n naught here with the little zero at the end, that's n naught. That stands for the initial amount, the amount you started with. So you can go ahead and plug this in here and solve the problem, right? You were given the half-life, so you plug in the half-life, solve for k, and then you can put k into there along with the time that elapsed, which is 5 years, and then plug in the initial amount that they gave us, which is 1.35 milligrams, and then just solve for NT, which is the amount after 5 years. Okay, that's one way to do it, and that's perfectly fine. But I think an easier way is just to use this equation right here. And this equation actually comes from these two. I'm not going to show you how to derive this equation. I do that in another video. So if you are interested in seeing that derivation, please watch that video on that derivation. But this basically comes from these two. And so this has everything in it. You don't have to do two steps. This has everything in it in one step, right? So here I have the amount of the radioactive substance that I have after a certain amount of time. That's equal to the initial amount I have multiplied by 1/2 raised to the power of this fraction, and the fraction is the ratio of time that has elapsed. That's, in this case, 5 years after 5 years, and the half-life. So if you know everything, you just plug it in this equation, solve for the missing part, and you're done. Okay, so this will like be a good equation to use if you're looking for a certain amount left over, or if you're looking for a certain amount that you started with, right? If you're looking for a fractional amount, all you need to do is divide both sides by n naught, right? So then, if you want to know the amount, the fraction that's left over, not the amount that's left over, but the fraction, you could just use nt over n naught, divide both sides by n naught, and you get that equation, right? So 1/2 raised to the time elapsed divided by the half-life. That's half-life. T of 1/2 is the half-life. So this, if you plug this in, you'll get the fractional amount after amount of time. If you want to know the percent that's left over after a certain amount of time, then you just take the fractional amount and multiply it by 100. So let me just rewrite this. So you would take the fractional amount, right? So if I want the percent left over, so like the percent left, that would be equal to the fractional amount multiplied by 100. So 1/2, right, raised to the t over t 1/2. And then, of course, this is then multiplied by 100. So these three equations are very, very helpful, and you can do it in one step. So let's go ahead and do this problem using this equation here. So I am given the initial amount, 1.35 milligrams. So I want to find, what do they want to find? We want to find the mass that is present after 5 years. The what is left after 5 years. So that's NT. And so that's going to be equal to N naught, which is the initial amount, which we are given 1.35 milligrams, 1.35 milligrams. And that's multiplied by 1/2. And that's raised to this fractional power. So it's the time they elapsed, which is 5 years. So I'll have 5.00 years over the half-life, which is 2.86 years. 2.86 years. Now, when you're doing this, it's important to make sure that the units of time you're given for the half-life and the time elapsed is the same. If they're not, then you got to convert one of them to get them to the same. Okay, so now here, the years cancel out, and now all I need to do is figure out what this number is, do the 1/2 to that power, multiply that by 1.35 milligrams, and that's it, right? So here, I'll just tell you what I'm doing. So I'm going to take 1/2 on my calculator. So 1 divided by 2 equals 0.5. Now I'm going to raise this to this fractional power. So I'm going to hit the X to the Y button. And then I'm going to divide this. This is going to be my exponent. So it's going to be 5.00 divided by 2.86. And then I get that fraction. And when I have this, now I have this. So I'll just write down what I got. So here, this is going to be 0.2, This is going to be 1.35 milligrams times, and then 1/2 to the power of this fraction is 0.29766 right? So then I take that number and then I just multiply it by 1.35 equals, and so then what I get is 0.402. 0.402 milligrams. So that, ladies and gentlemen, is the amount of my substance in milligrams, that's polonium-236. This is the amount that I would have left over after 5 years. So that's how you can use this equation in a one-step calculation to solve this problem. So, and others like it. So I hope this is helpful. If you enjoyed this video, if you learned something from this video, then please, by all means, like the video, share the video with your friends, hit that like button. Also, subscribe to my channel. Make sure you hit that notification bell. And when you do, please make sure you click all so you can be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me hear from you. I would love to hear from you. You can ask me questions, you can make comments, you can make suggestions, whatever your heart's desire. Thanks for joining me and have a great day.